Hello and welcome back. In this question, we have a child and a sled being pulled by a person with an unknown force. The child and the sled have a total mass of 23 kilograms and the coefficient of friction between the sled and the snow is 0.14. So in the first part, we're required to draw the free body diagram, which is pretty straightforward. So you got the weight force, which is always directly downwards. You have the normal force, which is perpendicular to the surface. You have the friction force, which is opposite to the direction of its motion. And we have the tension force, which is being pulled at 10 degrees above the horizontal. And that's how the free body diagram should look like. Okay, now with part 2, I'm going to do the analytical method. And it's going to involve a lot of algebra. Okay, so with part 2, I've decided to go with the analytical method. Now, it is going to involve a lot of algebra, but it's something that you've been doing quite a lot in the past year or so. So first thing is apply the equations of equilibrium, which in this case will be sum of forces in the y direction and sum of forces in the x direction. But before we do that, let's break up the tension force into its x and y components. So we have tension going this way. This is my horizontal, and this is my vertical. Remember, head, tail, and the resultant is always tail, 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 and head, head. So there's my right angle, there's my 10 degrees. So the horizontal component, Tx, is going to equal to T cos 10, and the vertical component is going to equal to Ty is equal to T sine 10. Alright, now that we've got that, we can now apply our equation. So sum of forces in the y direction is equal to 0. And I'm going to consider that as positive. So we've got the normal force going up, so that's positive. Weight force going down, negative. And we've got the tension force going up, which is T sine 10 equals 0. So N minus my weight force is mass times gravity, which is 23 times 10. So that's 230 plus T sine 10 equals 0. Now make the normal the subject. And that's going to be 230 minus T sine 10. Alright, now that we've dealt with the sum of forces in the y direction, now it's the sum of forces in the x direction's turn. So sum of forces in the x direction is equal to 0. And I'm going to take that as positive. So I've got the frictional force going to the left. And I've got the tension force, the x component of the tension force, which is T cos 10 equal to 0. Now the frictional force can be written as coefficient of friction times normal force, which you can find in the formula sheet, and that would give us 0.14, that's given in the question, times the normal. So now going back to the equation, we now have minus 0.14n plus T cos 10 equals 0. So we have 0.14n equal to T cos 10. So now sub the equation that we got for n into this equation here, and you get the following. 0.14 bracket 230 minus T sine 10 equals T cos 10. Expand that and we get 32.2 minus 0.14 T sine 10 equals T cos 10. Move the T's to one side, so we have T cos 10 plus 0.14 T sine 10 equals 32.2. Now take the T's out, so factorize T out, so we got T bracket cos 10 plus 0.14 sine 10 equals 32.2. Divide both sides by cos 10 plus 0.14 sine 10. And you get T is equal to 31.9 newtons. And so there's your solution. So to sum up, apply sum of forces in the y direction to get an equation for your normal force, then apply the sum of force in the x direction. Once you've got that, substitute the n equation into the 0.14 n equals t cos 10 equation, and then it's up to your algebra skills to solve the value for t. So put all your t's on one side and the numbers on the other side, factorize the t out, and then divide the coefficient of t on both sides to get your t value.